We are doing the working of a DC motor. This is the diagram of a DC motor. There is a rectangular coil and we will send current in the coil. So how the motor works? So when the switch is closed, current passes through.
That this is, can you, if I can get to know from syllabus or what, this chapter is which chapter?
Electromagnetism, magnetic effect of current. In the new
Like,
syllabus, actually made a decimal numbering, 2.1.1, 2.1.2. Now it's not that much clear. It used to be 1, 2, 3, but now after 2022, they have made a numbering like the decimal coding, like the versions of a software. But I will show you. First, you complete this working with me, the working of the motor. When the switch is closed, current passes through the rectangular coil this produces a pair of equal and forces on facing edges of the coil. This tends to rotate the coil in one direction.
so what is here, like this produces, when the switch is closed, the current passes through the rectangular coil.
There are two forces. Forces are produced on the rectangular coil. Please look at the screen. This is the rectangular coil. When you pass current, look at the screen. One side the force is downward and the other side force is upward. This is just like a bicycle pedal.
Yeah.
And what happens? The coil will try to move in one direction.
Okay. So can you go back to the screen, please? Once again.
Yes, this is the screen.
Okay, done.
Now, you have to copy this diagram neatly. Please copy it. I'm just coming. Copy it. There is no force on the side BC and AD because they are parallel to the magnetic field. Have you copied it?
Yes, sir, I have copied it.
Okay. So two concepts to come again, that motor is working on the principle of left-hand rule. It is like a bicycle. When you put two pedals to put two forces, the motor coil rotates. The coil rotates and this is called moment. After half cycle, the coil cannot rotate further and it comes backward. This was a technical problem with the motor design because the forces are in the same direction. After half cycle, the coil flipped back and it was not ready to rotate fully. They wanted the coil to rotate in one direction. This is where they introduced the concept of split ring commutator, a very important concept. And whenever motor comes in the paper, this concept is there. This is called, look at this diagram, this is called a split ring commutator. It is like a rotating switch. When it is connected in the motor, it stops the current after half cycle. In the above diagram, current is going in the circuit. But in the lower diagram, there is a gap. The brushes are not touching the half rings, so current will stop. This is how the circuit works. This is called a DC motor. There is a gap. There is a gap between the two brushes. There's a gap between the two rings. Please look at carefully this gap. There is a gap in between due to which the motor coil does not rotate completely until the gap is there. So the concept comes here. A split ring commutator stops the current after every half cycle. Look at this. This is an iron ring and this golden color thing is the split ring. You have to look at this animation because this concept is very tricky. Look at this animation carefully. This is motor coil. It's moving. Carefully see, can you feel the current stops at a point? Look carefully. Do you notice the current stop at a point? Yes, Ahmad, can you reply? Are you there?
Yes, sir, I'm here.
So can you reply?
Yes, I can see the animation moving. The force goes upwards, then it rotates too.
But can you see the current stops in between when the brushes have a gap? Can you see the flip? Current stops.
Yes, I can.
I play it again. Look at carefully when the current stops.
Yes, sir, I can see.
But when the split ring gets a gap with the circuit. Please give me your full attention to I can explain this difficult concept again.
Okay.
Can you see what happened when the split ring comes in gap? Look, when the gap comes, the current stops.
Yes. It stops, right?
Yes.
So why does the current stop here?
Look the animation again. Can you see the gap? Current cannot jump through the gap. Look at the animation. Carefully see, it's a very technical concept. Now see, gap is coming. Now gap comes. When there is a gap, current cannot pass because current cannot jump through a gap. Okay, did you see the gap issue, the split ring? Split ring means half ring.
DC motor. Electric motors are everywhere. Almost every mechanical movement that you see around you is caused either by an alternating current or direct current electric motor. Here, we are going to explore a DC motor. A DC motor is a device which converts electrical energy into mechanical energy. A current-carrying wire in the presence of a magnetic field will always have a tendency to move. This effect is known as motor effect. Want to watch the motor effect? Wind several turns of wire around a cork and suspend it from a clamp. Place this arrangement between the poles of a horseshoe magnet. Switch on the current. The cork moves. Now, reverse the direction of the current. The cork moves in the opposite direction. This experiment shows that the magnetic and electric fields interact to produce a mechanical force. This is the principle of an electric motor. The direction of motion is given by Fleming's left-hand rule. Fleming's left-hand rule. Extend the thumb, forefinger, and the middle finger on the left hand in such a way that all the three are mutually perpendicular to each other. If the forefinger points in the direction of the magnetic field, the middle finger in the direction of the current, then the thumb points in the direction of the force exerted on the conductor. A rectangular coil made of insulated copper wire is wound on a soft iron core. This is the armature. The coil is mounted on an axle and placed between the cylindrical concave poles of a magnet. Thus, the armature becomes an electromagnet when a current passes through it. A commutator is used to reverse the direction of flow of current. Commutator is a copper ring split into two parts, C1 and C2. The split rings are insulated from each other and mounted on the axle of the motor. The two ends of the coil are soldered to these rings. They rotate along with the coil. Two small strips of carbon, known as brushes, press slightly against the two split rings, and the split rings rotate between the brushes. The carbon brushes are connected to a DC source. When the coil is powered, a magnetic field is generated around the armature. The left side of the armature is pushed away from the left magnet and drawn towards the right, causing rotation. When the coil turns through 90 degrees, the brushes lose contact with the commutator and the current stops flowing through the coil. However, the coil keeps turning because of its own momentum. Now, when the coil turns through 180 degrees, the sides get interchanged. As a result, the commutator ring C1 is now in contact with the brush B2, and commutator ring C2 is in contact with brush B1. Therefore, the current continues to flow in the same direction. Again, brushes and the split rings lose contact when the coil turns through an angle of 270 degrees. The coil has a tendency to stop, but due to inertia.
Now look at this rotating concept again. The red line in between, this is called a motor setup. The motor coil is moving and the current stops after every half cycle. The green forces disappear for a short interval. Okay, Hamad, did you look at these two animations? Are you there?
Yes, sir, I was watching.
Okay, now look this very nice concept, but it's a low resolution one. but it can make a very good concept. This is a very difficult concept, split ring commutator. Now look at this animation.
In this simple electric motor, a current passes through a coil in a magnetic field. This forces the left side of the coil upwards and the coil rotates. When the coil is vertical, the current shuts off for a second. The current is reapplied and the other side of the coil moves upwards. This is the simplest model of how electricity creates mechanical energy.
An electric motor is a machine that uses electric energy to produce motion. Electric motors operate a variety of devices, from vacuum cleaners in the home to windshield wipers in the automobile to conveyor belts in the factory. All electric motors that produce rotation work in essentially the same way as a direct current series motor, which is commonly used to drive electric railroad cars. Current flows through a wire to a block of graphite called a brush. The brush transmits current to the commutator, which consists of 2 or more semicircular split rings. The commutator is connected to a large coil of wire called the armature and to the output shaft. Current flows from the commutator through the armature, then back to the commutator. Current then flows through another brush to 1 or more electromagnets, each made up of a wire coil wrapped around a piece of iron. This flow of current through the magnet's coil produces a field of magnetism. The field has a north pole and a south pole, as shown in this simplified picture. The current in the armature, one loop of which is shown, interacts with the magnetic field in the coil, producing motion. The direction of this motion depends upon the directions of the field and the current. The split ring of the commutator interacts with the brush to keep the armature current flowing in the same direction relative to the field. Thus, the loop and the output shaft continue to rotate in the same direction.
Okay, now you have to copy this screen. After half cycle, the coil cannot rotate further and it coils backward. Please copy and update once you have copied it.
Sir, can I get like uh, we have watched many animations. Can I get just a quick recap?
This is the same concept, na, which I'm coming back to the same concept after showing you the animation. I'm going to discuss the same, that motor coil is rotating by current. And now we have to discuss again that what is the purpose of split ring commutator. So I'm not going forward. I'm actually back on the same concept, which I was showing. So I have to copy this.
And so after this chapter, we can start with radioactivity.
No, we have to do electromagnetic induction. It's a connected chapter. After that, you can do radioactivity because we are nearly over with this big chapter. And after that, EM induction comes and then nuclear comes. Have you copied it?
Yes, sir. Done copy. Yes, sir. Done copy.
Good. Now to obtain a continuous rotation, for which I was showing you all the animations, to obtain a continuous motion of the rotation of the coil, split ring commutator is used. A very important concept. You have to copy it in inverted commas. Okay, have you copied it?
Yes, sir, to obtain a continuous rotation of the split ring commutator is used. Okay.
This is called a split ring commutator. Look at it carefully. And this is the motor complete diagram. In the paper, examiner can ask you to draw a diagram to showing the brushes and the split ring, which we have seen in these animations. These are called motor. This is called the motor diagram. It shows rectangular coil, carbon brushes, split ring commutator. The motor coil rotates due according to Fleming's left-hand rule.
Yes.
The split ring commutator has two positions. In this position, in the diagram, in the first position, current enters the coil. But in the second position, look the second diagram on the page, current does not enter the coil. Current does not enter the coil because there is a gap. Because there is a gap. So now right under it, that split ring split ring commutator when the
And the
when the gap
okay.
with the carbon brushes. But the coil does not stop. Why? If you are running a fan, Hamad, and you switch it off, if you are running a fan and you switch it off, does the fan stop immediately?
It takes 1 or 2 minutes to stop properly.
Why? In physics, why? When you are cycling, you stop pedaling, the bicycle does not stop immediately. Why?
Because the power is already there and it's moving until like
No, read the screen. Coil
split ring
continues.
commutator stops the source current when the gap line
Line
up with the carbon brushes. The coil continues to move due to inertia, which is momentum.
Okay, now answer the same question. Why a fan does not stop immediately when you switch off the circuit?
Split ring commutator stops the source current when the gap line up with the carbon brushes. The coil continues to move due to inertia, which is known as momentum.
When you are bicycling, when you are cycling and you stop pedaling, the bicycle continues due to inertia. Right? When you are cycling and you stop pedaling, the bicycle does not stop immediately. Why it does not stop immediately? Due to
Inertia,
due to
momentum.
very good. Now copy it completely. Copy this screen. Have you copied it?
Yes, 1 minute. 1 minute, please. The last one I have to write it. Okay, done.
Split ring commutator provides continuous rotation of coil. It also provides a dynamic contact. Something is moving and you want to transfer current. This is called dynamic contact. Split ring commutator provides a sure continuous rotation of coil. It also provides dynamic contact. You have to copy this.
So what is dynamic contact and the continuous rotation for a coil? I have written it.
Rotation of coil, I have explained you thoroughly in this animation, and I have shown you this animation and other animation. It means the coil will continue to move. Look at this animation again. This is called continuous rotation of the coil. Look at this again. Can you see current stopping?
Yeah, when there is an empty place, the current stops the flow.
Ah, very good. Now you got it. This is called continuous rotation of the coil. Dynamic contact is what? It is actually the concept of moving contact. Something is moving and you want to transfer current. So you need a contact like that. Otherwise, if you rotate something with an electrical circuit, the wires will be tangled and wire will be broken. So actually, this setup provides a dynamic contact. If you look at this animation again.
In this simple electric motor, a current passes through a coil in a magnetic field. This forces the left side of the coil upwards and the coil rotates. When the coil is vertical, the current shuts off for a second.
Now look at this idea that something is moving, but our wires are not being tangled. Otherwise, if you move something, if you move the wire, it will be tangled. Look at this animation, a very nice concept. that the coil is rotating. Look the sketch. It is in one direction. It's not flipping back. So we have done the most difficult concept of electromagnetism, split ring commutator, and we keep it up to here. And we will inshallah continue this in our next class. Allah Hafiz.